Well, let's try another example. This time we have an application. A farmer plans to fence in a rectangular pasture adjacent to a river. And I put a little drawing down here of the situation. The pasture must contain 245,000 square meters in order to provide enough grass for the herd. We ask what dimensions will require the least amount of fencing if no fencing is needed along the river. Well, okay, this question seems like it would be kind of difficult, except for the fact that we know two things. We want to find a fixed area, and we're told what that area is. That area in this case is 245,000 square meters. Okay, and we know that if we have a rectangular pasture, it doesn't matter where the fence is, its dimensions are length times width. So we could say that, well, 245,000 is equal to our length times our width. Now, that's not very helpful because we've got two variables going on right here, and it's not as though we can write. And what we want to do is we say, well, what about the amount of fencing? How do we calculate the amount of fencing? Well, if we call this our width and we call this our length, what could we say? Well, in this case, there are two widths right here and one length. Now, maybe you suspect that this is going to be like a square or something like that, but we're going to have to see. What we have to minimize, though, is the amount of fencing, and that's a perimeter. So what we really need to do is we need to build a function that we're going to minimize. So if we're asked to minimize something, we say, well, what do we minimize? The answer is the perimeter. And do you know how you get a perimeter? Well, in this case, the perimeter just means adding up all the sides. So we're not going to say two widths plus two lengths because we don't need any fencing along the riverside here. We just have one length. So it's going to be 2 times the width plus 1 times the length. And we need to minimize the perimeter. And so it turns out that this area formula for us is really a way of helping us rewrite this perimeter formula in terms of one variable or the other. And I could tell you that in this case, the length will end up being 245,000 divided by the width. And so the perimeter formula we're going to need is in terms of one variable, and we're going to make that variable our width, w. So the perimeter as a function of w is going to be 2 times the width plus 245,000 divided by the width, w. Well, this is the function that we're going to have to find our derivative of in order to make this work. So now what we're going to have to do is we're going to have to find p prime. So let's see. Let's how do we treat this? Well, this is 2 times w. The derivative of 2 times w is just 2. 245,000 over w is the same thing as having w to the negative first, right? If we wanted to rewrite this one more time, we could have said 2w plus 245,000 times w to the negative first power. So we're going to get a derivative that is negative 245,000 times w to the negative 2. Well, another way of saying that is p prime is 2 minus 245,000 divided by w squared. Next question. Where will we find our minimum? Well, we might find our minimum where p prime is undefined, and we know that it's undefined at the point where the width is equal to 0. But that's no help, right? Because if you imagine it, if the width is equal to 0, that means we've just got this huge, huge long fence along the river with practically 0 pasture land. That minimizes the area but doesn't give us 245,000 meters. So that's no good. So that's no help. right? But what about where p prime is equal to 0? Well, that could be some help. Maybe we might be able to find where 2 minus 245,000 divided by w squared is equal to 0. So we ask the question, how do we solve this? Well, okay, algebra time right here. We set this equation equal to 0. That means that 2 is equal to 245,000 divided by w squared, which is say that 2 times w squared is equal to our 245,000. And if we divide both sides by 2, as we should, in order to isolate w squared here, that's our goal, isolate w, right? We actually find 245,000 divided by 2 becomes 225,000. Whoops. Change that. It's not 225,000. A little off there. 1,225 here. So 1,022,500 is half. And so we would have to take our square root. Now, we would normally say plus or minus, but in this case, because it's only a real dimension, we're not going to take our negative root. We only are interested in the positive root. Now, I worked this one out. I'm sure you could work this one out too, but I come up with w is equal to 350, which you can verify for me. So the width would have to be 350 meters. That's getting somewhere, because if the width now has to be 350 meters, what does the length have to be? Well, this is where we go back to our formula for the area. We were told that the area has to be 245,000, so the length is going to be 245,000 divided by 350, and lo and behold, when you do a little bit of algebra here, when you do the work, you do the division, you come up with 700 meters. And so the dimensions of our pasture land would have to be an enclosure that's 350 meters wide, 700 meters long. Well, that's pretty good for a day's work. I'm sure the rancher's tired, and so are you. Let's try again with another one later.